going to demonstrate the line and phase quantities of three-phase star connected load. So here I am going to measure line and phase currents in a star connected load. So for this I need a three-phase supply, an auto transformer and a three-phase lighting load. So here I have three-phase supply. So from this, when you switch on the MCB, you get a three-phase supply, and from there RYB terminals, and that one I am giving to the auto transformer. This is three-phase auto transformer. These are the input lines incoming, and these three are the outgoing lines. Then I need a resistive load. So here I am using lighting load. So this is R phase, Y phase, B phase. In the three phase I am using lighting load, and I need voltmeters and ammeters to measure the line and phase quantities. So here I have the voltmeter and ammeters in both the line and phases. Okay, now I will show you the connection diagram. So here this is a three-phase RYB supply. So this is three-phase RYB supply. From this I am giving to auto transformer. So auto transformer B1, B2, B3 are the three inputs, and E1, E2, E3 are the outputs. So from the three-phase supply to the auto transformer I am giving, and from the auto transformer I am taking from E1, E2, E3 terminals. So this is the first line, second line, third line. So from the first line, first I am giving a ammeter. I am connecting an ammeter in the first line. So this will give you the line current, and from there I am going to give the load. So here I am connecting one load, lighting load, what I have shown in the previous video. So that load I am connecting here. Similarly in the Y phase and B phase, three loads I am connecting, and also I am connecting an ammeter in this phase. In this phase I am connecting a meter. So this will give you the phase quantity. This will give you the line quantity, and this will give you the phase quantity. And then this E2 I am giving connection to the second load, second lighting load, and from E3 I am giving to the third lighting load. Like that I have to give the connections. Later I have to connect the voltmeters. So this voltmeter V1 I am connecting in between the two lines. This will give you the line voltage, and also I am going to connect one voltmeter that is connected between the R and the neutral. Between the terminals R and the neutral I am connecting. This reading will give you the phase quantity. So the voltmeter connected between R point and N point, this is a phase quantity. So to measure the phase voltage I am connecting voltmeter here. This will give you the line voltage, this will give you the phase voltage. So this is the connection diagram. Circuit diagram I am going to give the connections. Now first from the three-phase supply to I am giving auto transformer. So this is the auto transformer input, and from the auto transformer output, so it has three lines, 1, 2, 3 like that, E1, E2, E3, we have three lines. So from the first line E1 to I am going to give the connection as per the circuit diagram. I am giving to the auto transformer ammeter. So this is my first ammeter. It is to measure the line current. So from this is the first connection. Similarly, I am going to give the second line to the second load. So from this I am going to give the second load. So from the first I have given to the ammeter, and this ammeter is given to the first load, and second is given to the second load, and third wire is given to the third load. Like that, for the three resistive loads I am giving the connections, starting connections. Later on, this ammeter is connected to the first load, and the ending point, it is a star connected load. So all the star connected loads, the end point should be connected. So for that common point connection, so I am connecting like this. So you can see this is the first load end point, and this is the second load end point, and this is the third load end point. So all the three loads end points I have to give connections, because it is a star connected load. All the three end terminals are connected together. So that will form a neutral connection. So now this is connected to the last one is connected to the second load end point, and this also should be connected to the first load. So in between, what I am doing, I am connecting an ammeter. So our first load end point to the ammeter I am connecting to measure the phase current, and this is connected to the end point of the Y point. Then to form a neutral point, I am connecting the B phase terminal to the end point to this end connection. So like that I am forming a neutral connection. Later on, to measure voltmeters. So to measure the voltage, I am connecting the voltmeters. So the first voltmeter I am connecting. So it is connected between the between two lines to measure the line voltage. So this is the first line. So in the first line and in the second line. So like this I am connecting the between the two lines. I am connecting my first voltmeter to measure line voltage. Next I am going to connect the phase voltage. To measure the phase voltage, as per the circuit diagram, you can see that the second voltmeter is connected between R point starting and R point ending. That is called a neutral point. So between R point starting and neutral point ending, I am connecting this voltmeter. So now I will show you the connection. So this is used to measure the phase voltage. So R point starting. So this is R point starting and R point ending. So between, it is connected across the phase winding. So this is a phase. Across the phase I have connected this one, second voltmeter, to measure the phase voltage. So like that we have to connect phase voltage, and line voltage is connected between two lines. Between two lines, this is a line, this is another line. Between the two lines I am connecting, so to measure the line voltage. Like it, we have to give the connections. Later on we will switch on the supply and we will find the line voltage and line current relations. Now I switched on the three-phase supply. Now I switched on the three-phase supply means, and then you can see, observe this one. The meter reading is 0, voltmeter reading is 0, everything, all meters reading is 0, because I did not set any voltage in the auto transformer. It is kept at 0 volts. That is why it is not giving any readings. Now I am going to set the three-phase voltage with the help of auto transformer. So with the auto transformer, I am increasing the voltage slowly. You can observe the reading changes here. So I am changing the auto transformer reading with respect to that one. Here the voltmeter reading also changing. You can observe this one. Now I am setting this voltage to three-phase voltage, rated voltage around 430 volts. It is 230, 250. And now I kept the voltage around 430 volts. Now it is showing around 430 volts. So with respect to that voltage, now I have three loads connected in star. So now the each phase currents, you can observe this one. This is a line current according to the circuit diagram. First ammeter, this is the first ammeter. So this is reading 0.4 amperes. So 0.4 amperes. And second, this is a second ammeter. It will give the phase current, that is 0.4. It is also showing 0.4. It's also showing around 0.4 only. Both are showing same values. And the line voltage I am set here 430 volts. The phase voltage it is giving 239 volts. It's around 240 it is showing. So the phase voltage here I got as a 239 or 240. So like that I got the phase voltage. So these are the only readings in the three-phase star connected load. So after setting three-phase voltage, corresponding readings we have to note. So now you can observe this one. In this, we know that in a star connected load, IL equals to I phase, because these two are in series. So IL equals to I phase. So that's why these two currents are showing same values. And we know that in the case of star, VL equals to root 3 times of V phase. So here VL equals to root 3 times of V phase. So we got V phase as a 240. So VL is a root 3 into 240. We are getting at around 215 volts. So we applied around 430. We got around 420 volts we are getting. So this is theoretically verified. So almost both are equal. So this I want to show in three-phase star connected load. So what's my conclusion is that the voltage is, the line and phase quantities of current are same because it is star connection, and the line voltage and phase voltage relation is root 3 times of V phase, that is proved here. Thank you.